All right. Good morning, everyone. What are the concepts we have seen in the yesterday session? What we have seen in the yesterday session? So DFS and BFS. That is example. Did you guys solve it? Only one I have tried, and there are some issues. So did others try? So please solve it and then find the minimum. I mean minimum BST and sorry BFS and DFS tree for that. What? Should I apply this? No? So this is what happens when you keep on switching. All right. In graphs, we have seen BFS and DFS, right? Do you have any queries in that? So what is the time complexity and space complexity of BFS and DFS? Huh? That is vertex plus edges. It depends on that only, right? Yeah. Yes. Okay. That means you have to store that. You can say order of n, which means n number of vertices. Okay. So the next topic is here we have 1, 2, 3, 4 algorithms. Okay. So this is we will talk about minimum spanning tree, MST. Okay. So now my question is, what is MST, minimum spanning tree? I have already shown some example, like there will be a graph with weights. Then you should find the minimum path from source to destination, right? So for example, yeah. So first let's talk about spanning tree, and then we will talk about minimum spanning tree. So if it is, the question is just a spanning tree in the sense. Now what is this? A tree or a graph? Why it is a graph? Because there is a loop, right? Yeah. And so spanning tree in the sense, I said that we need to minimize the edges to eliminate the loop. So can you say this? Is this okay? You have to connect all the vertices. You should not miss anyone, but there should not be any loop. If it is A to B, A to C, and A to D is connected. This is one type of spanning tree. So like this, you can draw multiple spanning trees for this. This is also possible. This is possible. This is possible. One more thing is also possible. So now, how will you find that? How many spanning trees that you should draw? For example, a question is given like this: draw the possible spanning trees for the above graph. In the sense that how many you will draw for this question? 6, 7, 8. There are 1, 2, yes, 1, 2, 3, 4. 4 types of spanning trees are given. Now my question is: do you understand my question? So how many spanning trees are possible for this? Huh? There should be. Yeah. Now, what do you think? What could be the formula? Not sure. Not sure. Are you not sure? Yes. So basically, you should have. If how many vertices are there? Vertices. 4. So for a spanning tree, you should have. We can say n minus 1 edges. How many vertices? 1, 2, 3, 4. Right? I said that n minus 1 edges. We can say d minus 1. I mean, number of vertices, that is 4 minus 1 means what? How many edges you should have? 3. Am I having 3 edges? This is how you can confirm. Like if there is a dense graph is given, then if you want to draw minimum, sorry, just a spanning tree, minimum in the sense you will be given some weights. That's it. That is the next concept. Just a spanning tree in the sense you just want to minimize the edges, right? And then you have to connect it with all the vertices. You have to make sure whether they're connected or what. Right? So here. Next, there is something called as MST. I said that there will be weights assigned, right? Weights will be given, and then you should find the minimum. Similar to the previous example, we are again making a spanning tree. Then we will call as minimum spanning tree because there are some weights. 4 plus 7 plus 3, the cost is 14. Now you have to find which is the minimum, which path will be the minimum cost. We will be getting. So this is again. I said that the graph concepts are used in Google Maps and all, right? So to find a route which is minimum from here to Delhi or whatever it is, so you will have possible routes like this, right? Different routes, 4 or 5 routes will be available. Then you will select a particular route. This, if I go in a highway, then there is a possibility of less number of kilometers I should travel. So similarly like this. So this is how it finds your different cities, kilometers and all. Right? And also this concepts are used in networking. Like if you are sending a mail from here to US, then through which network it should travel. So it should find a minimum network. There are multiple networks, right? So that's how it goes. Do you understand what is a spanning tree and minimum spanning tree? Yeah. So these are all the applications. As I said that you can use it for network designs and even airline routes. And even if you are making this geo optical fiber, they are laying that on the road, they dig, and so even there they will apply the shortest path because it is costly, right? That optical cable. So even for BSNL we have that optical fiber network. So they will find the what will be the shortest path from here to Ahmedabad, and through that they go for. So they apply this algorithms, which means that they don't know they are applying, but in the background these algorithms are working. So that's what we understand. I mean, if I'm just using an app, I don't know what algorithm they have done. I'll simply click source to destination, then I'll click on find or search. It gives me the result. But in the background, a programmer should understand. I mean, a programmer should know what to use and how to develop that program, right? That's what I'm saying. Yeah. And I said that routing algorithm, there are, again, it is like a traffic routing. If you have seen that, have you seen that video, The Dawn of Internet? You can go to YouTube and you can type DAWN, Dawn of Internet. So that is a video which all UG students should watch while learning the computer network subject. Still, it is not there for you, but I'm just letting you know. It shows how our message travels in a packet. From here, if I'm sending a message hi to someone in Singapore, so how it travels. So there will be different TCP, IP, router and switch. These are all the hardware devices I'm talking about. So again, over there, it works based on some algorithm. That is again a routing algorithm. Over there they use, because now again they have to find the minimum path to deliver my message, so that the cost will be less for them. For that they use this one, minimum spanning tree again. That is called as MST. Yeah. So so there are two famous algorithms which uses MST. One is Kruskals and another one is Prims. Okay. So you can take down these names. This is Kruskal algorithm and Prims. So both I mean, in both we will get the same results in the sense both works in a similar fashion. Like the both algorithms objective is to find minimum path, right? I mean, we have seen minimum spanning tree, right? There is a different routes, and then finally we calculate the cost of that particular path from source to destination. So likewise, we're gonna calculate the same for these both algorithms, but in different way. Like in DFS and BFS, in BFS we select all the adjacent nodes and then we will add it in queue, right? But in DFS we will select only one adjacent node at a time. We'll put that one in stack. That is the only difference, right? Over here there is a similar kind of differences there. I'll let you know. Okay, so Should I go with this example or small example? Yeah, I can go for it. So there is a graph like this. Right? This kind of graph only will be given. There will be not any, 4 or 5 edges or vertices. There won't be something like that. So what happens here is, what you want to do is that first you have to find the possible subsets of this graph. For example, if I take from A to B to A I should not take because I will repeat this number again, right? So A to B to E, B to D, D to. So I just want to take this subsets, and can you see this? These are also basically edges from where to where you are taking. Like from D to E, the cost is 1. It is given in the graph. So you just list everything here. And then while listing, you won't get it in this order, right? Now this is in sorted order. So you just make a rough table first of all, and then sort it based on the weights. Right? Now I have 1, 1, 2, 3, 3, 3, 4, 4, 4, something like this. Right? Are you getting my point? You will be given a graph. You just want to find similar kind of graph. You just want to first write H to G is 3, G to E is 3, something like this. But it won't be in sorted order, right? So what you want to do is you have to sort those subsets, I mean edges, in this way. So then you will have a ascending order one, right? Now what I want to do is that I just want to connect all these edges, and then there is one rule. For example, first I'll take D to E. Where is D to E? Here I'll say, and then I'll mark it as 1, and D to D here. Then E to G is there, right? I will do like this, which means there will be a loop, right? Whenever a loop comes, you should avoid the loop. I mean, I should cut this one. I don't want to take that one. I should not form any loop here, close to loop. That is the rule. So now can you connect this on, so that you will be getting a minimum spanning tree. You can avoid wherever you get loop, you should avoid that. That's the only concept here. So you can take this question first in your notebook. So guys, who are online, I want your participation also. Just solve it and just let me know the answer. Don't just stay idle. Fine? So even you can directly make this answer, like without making anything. You can simply start from A, D, 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 F, C, and you can connect. There should not be any closed loop. That's it. What we are trying to do is that we are trying to do step by step. Right? If you understand that, then you can go for direct answer. Just for cross checking. Don't do that direct answer in your answer book. Okay? Did you copy this? Yeah. And my answer shows something like this. Is that correct? So what I have done here is that I have taken all the edges and I have sorted. And now this is in a sorted order, right? Like 1, 2, 3, 3, 4, 5, 6, 8, 10. So I'll start connecting. So first I have started D to E, that is 1. Then D to G, 2. I said there is something called as E to G. I should avoid this because if I draw this one, E to G is here, right? If I take and draw this one, there will be a loop like this, right? So I have avoided, which means I have deleted this one. You can see that. You can omit that particular thing. Fine. And I have to keep on proceeding. So which means that there is no loop here, here, here. So this is now. What will be the cost of this? I want to know the cost. What is the cost for your answer? You just write the cost from the graph, from the question. Huh? 23? It's not. I'm getting 21 here. I want to know that how much you have got. Okay? A2? If you do that, then you see this A to F will be in a closed loop. If you do that, then you just avoid this part. A to F also you can connect. A to see, first I'm starting with A to F. Okay, no problem. Connect like this. But somewhere you have to avoid one of the edges here. That is also right. I'm not saying this is the final answer again. It depends on where you are starting. So as you said that if I start from A to F is there or what? Yeah, 10. Then I will draw here. A to F is 10. Then I will go with like this. But I should not connect A to F and all these things like this. Then there will be a loop. I should avoid one of the edges. So that's why I have avoided A to F here. Right? Do you understand what I'm saying? So now my question is: do you feel that this Kruskals, what he proposed is seems good or what? Do you think that this kind of approach is good or bad? Good. See, but there is a problem, right? Which means where to draw? Yeah. So I have taken what first? E2. This is E and E to D, like this, right? And D to E, and then D to G, something like this. Then where is E to? I avoided this loop. Then C to D is there. Where is C to D? So it comes from C and D. So I'm just connecting based on my edges over here, which means that I might connect H to G also. Then somehow I will try to connect like this, right? I feel that this approach is not that much good, because what we are doing is that we are going through the whole graph, and we are sorting the edges, I mean the weights, and then we are connecting it. So this is Kruskals, right? The same example can be taken. And what Prince saying is that, I'll go to the same example. Yeah, what he is saying that start from A or anywhere you want. So I'm starting from here. So what are the adjacent nodes of A? For A, F, B, H. Now you have 3 adjacent nodes. I mean edges. Select minimum from these 3. 5, 8, 10, what? A to H. Then go to there. Then you will be there in H. Now again find the adjacent nodes of H. H to B, H to G. Then find the minimum of this. Then you will go 3. So this approach is something good, because in Kruskals you might have while constructing a tree, you might have a disconnected node edges first, then finally you will get the answer, right? But here there is no possibility of having a disconnected node, because you are starting from here. From there I'll keep on finding the minimum one, and then I'm passing through, which means that there is no this kind of situation. Because in Kruskals there is a possibility first I'll connect this part and then this part and then maybe here, then from here, then again I'll say this is the answer. Again, you will get the same answer for this. Can you try? Huh? Prince. Yeah, I mean different approaches are there, but the beauty is that you will get the same answer. So can you try? Prince. Now, do you understand what is Prince? Eh? Who is Prince? That is Prince. This is Prince. So try it in a similar fashion. Okay, you just try and let me know the minimum cost. See, guys who are online, what I'm saying is that the difference between Kruskals and Prims. So now this is the graph which is given to you. Fine. Okay. So I will go to presentation mode. So now you have to follow my cursor carefully, guys who are listening online. So now I'm talking about Kruskals. So what you want to do is in Kruskals, this is the given question. So you have to find the possible edges, which means first A to F, there is a edge, so the weight is 10, right? You should write A comma F, then the weight is 10, right? And F to G, that is 3. C to D, that is 3. And D to E, that is again 1. So something like this. Don't repeat. For example, if I say E to G, that is 3. Don't write G to E, because again you are going in the same edge, right? Avoid that one. So like this, you have to find the possible edges, which means that you will be getting these many edges, fine, and you will be getting these many weights for the edges, right? The thing is that you might not get all these things in a sequence way. So now you just align this one in a sequence format based on the weight. For example, weight number 1, D to E, this edge has weight 1, which means you just put that one in the first. So ascending order. Align. What's going on? So you just align this, sorry, sort this weights like this, fine. Then you start connecting this edges. For example, D to E is there, that is 1. So D to E, that is 1. Okay, I'll connect here, I'll draw an arrow, I'll take pen, yeah. And D to G, there is 2. D to G, this is 1, and then this is 2. And you see this E to G is there, that is 3. But if I do this one, there will be a loop, right? I should avoid this. You should not construct any loop. So you should avoid this. So I have cut that one. I have omitted that one. I mean, you just leave that one. Fine. So likewise, you just want to look for other edges to connect. So once you do this, you will be getting the result like this. See, I have avoided this part, because all these forms a loop, right? You see this B to E. B to E is there. For example, this will, if I connect, it will form a loop. This is a loop again. So that is not allowed, right? So hope this is clear for you. Fine. So finally, you will get this answer, and this is not the final answer. It varies, like from where you are starting. Okay. So now the cost, you just want to add all the cost. So it will be like 21. So this is Kruskals. Fine. So now I'll talk about Prims. So for Prims, it is again very easy. I have taken the same question. You can see that. I mean, same graph. And what you want to do is that you have to find the minimum path. For example, if I start from A, the adjacent nodes are 10, 8, and 5. So out of these 3 adjacent nodes, I should find the minimum one. So which means that what is the minimum one from this? 10, 8, and 5. 5 is minimum. Okay. Now I will proceed on this route only. Then for H, H. So how many adjacent nodes it has got? It has got 4 and 3. Now what is minimum in this? 3. So I'll proceed in this way. Fine. So similar fashion. Again, you should avoid loops wherever you get it. Then the answer will be different. I mean, you will get a tree without a loop. So the answers are going to be similar for Kruskals and Prims. Fine. So this is the concept behind Prims and Kruskals. So this is for Kruskals. The time complexity for this Kruskals is like n log n. Here I have written e log e. That means edges, depends on number of edges, right? Uh, 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 and this is some additional point for you. I told you that they will use this graph concepts in making. Even here we have this electrical connection wires. So they will plan like how can they minimize this, installments. They have this pipeline connection for these wirings and all, right? Everything is about that one. Like they want to select a shortest path, right? And again, I said that in networks we use LAN connection again. This cable even, they do that. So, and for prims, what is the result? Have you got the result for prims? Huh? 20? Did you get something like this? Declared. Good. I guess so many have got good marks. What? 28. Yeah, I think 28 is the maximum mark I have given. No, 29. Someone is there. You can check that in some paper I might have written GP. GP. That is good presentation. So let me know that. I just want to know. So did I follow the same condition which I explained here for prims? Here I started. Then I have selected the minimum path, that is 5. Then from edge, there are 2 adjacent nodes, edges. 4 and 3, the shortest is again 3. So likewise, I'm keep on proceeding. Wherever I get loop, I should avoid this. I should not connect D and E because this contributes. From D. From D, I have got what? 3, 1, 6, 2. Then what you are saying? So you are saying how we have got to E.
I am not getting the connection F and C.
Where is F? Yeah. So you are not getting connection for this, then you might be getting any one of this. I mean, this is not the final answer, right? It depends on how you choose. But here I have started with A. When you start with A. Let me just go to a presentation mode. Do we have time? Yeah. Should I draw here? Okay, now just tell me like how should I proceed? So I'm starting from A. Not writing. Yeah. I couldn't write. I think I have some issue with this. Let me just try. Yes. So what I do, I'll start from A. Then uh, 10, 8, 5. Out of these three, 5 is the minimum cost. Then I'll say H. Then from H, I have 4 and 3. So I'll go to G. Let me take this as 3. Yeah. From G, what are the possibilities? Uh, D and E. So I have got what is what is minimum? 2 and 3. So D is minimum. So this is 2. Yeah. And from D, yeah, D to E is there. So because that is 1, right? Basically. Yeah. Then from D, you have got what? From D, you have got 6, 3. 6 and 3. No, from B, you have got 1, 2, 3, 4 possibilities, right? But these two are already visited. Then I have got 6 and 3. So I will go to what? 3 or 6? I'll go to 3 because 6 and 3, 3 is minimum. So that is C here. Then from C, what should I do? Because out of 6 and 3, 3 is the minimum one. So I'll choose that is. Then from C, I have got again what? 3 and 4. 3 and 4. Right? So again, I will go to what? F and 3. And from F, I have got 10, 4, 6. Then I'll choose 4. Then I'll be here, somewhere here. Is that correct? Then from B, if you draw anything over here, can we draw it? Is it possible? Yes. Will it form a loop? Then stop. Then stop your algorithm. If there is any unvisited, check whether is there anything unvisited or what. There should be all visited by this time. So what will be the answer for this? 21. You will get it. Simple. Right. So prims is very easy. This is prims. Okay. What you want to do is that select any vertex and select its adjacent nodes. Select minimum from that adjacent node. Minimum edge. So I have taken A and then 10, 8, 5. I should choose 5. Then from that I need to keep on checking in a similar fashion. Then wherever loop comes, I should not select B and B because this forms a loop. Right? That should be avoided. That's it. So for the same thing, we have applied Kruskals also, right? So how? In what manner I have applied Kruskals? Yeah. So I need to take these two edges, like I mean, A to H is 5, H to G is 3. I need to write down all such things, and then I need to put everything in ascending order, right? And then I have to start connecting, right? So basically, that Kruskals is called as disjoint edges. I mean that this keyword is very important over there. Why I'm calling Kruskals as disjoint? I am saying that disjoint because again I gave you the reason. Like you might connect this and this first, you might connect this and this, and finally you might connect here. Which means initially it might be disjoint. I mean there might not be proper connection, but at the end there might be. But in prims, you are not doing that. You are selecting a vertex, right? And then you are keep on going on. So there is no disjoint in between, right? I mean, I'm continuing the process. So here, in Kruskals, first you will see here, I can connect simply like this also. I can take BH and I can start from here. Where is BH? Yeah, I can start from here also, or I can start from there also. But you should avoid loops. So in that way, if I take in zigzag mode, again it works. But I'll take BH first, then DE. I can connect like this also, na? This one, then finally I will come up with the result. That's why I call this as disjoint edges. It might have disjoint edges initially. Maybe a question they might ask, instead of asking directly like explain Kruskal's algorithm, they might say explain disjoint algorithm or disjoint edges algorithm, something like that, in a twisted mode. Then you might know the answer, but you don't know the question. Then you will leave the 8 marks. You will lose 8 marks. So be clear in that. So yeah, take down this example. You have to try Prince and Kruskals for this. Make it fast. Uh, Guys who are online, did you copy this graph? I want trims and Kruskals algorithms to be applied to this graph, and do please let me know in the next session. I'll start from you guys who are online. I'll ask for the answer, and you guys please let me know in the next session, and then I'll proceed with the session. Even fine. So, is there any queries, guys? You have got in Prince and Kruskals, guys who are online. Can I have some responses here in the chat box? Yes, no, or still you have some doubts? Are you guys listening? Are you guys with me? Surya Bali Thakur.
Present, sir.
Yeah, I'm not taking attendance. Okay, I'm just asking whether you are listening, or you have got the point, or what. Yeah. Okay. That's good. I hope that you understood that what I'm expecting from your answer paper. I hope that you will do that one in midsem too.